Hi, welcome to the lecture 3 of internal combustion engine and gas turbine. The topic is carburation. Now, the types of carburetor. There are three general type of carburetors depending on the direction of flow of air. As shown in this figure, the first one is the updraft type, in which the air enters at the bottom and leaves at the top, so that the direction of flow it's upward. The disadvantage of the updraft carburetor is that it must lift the sprayed fuel droplets by air friction. Hence, it must be designed for relatively small mixing tube and throat, so that even at low engine speed, the air velocity is sufficient to lift and carry the fuel particles along. Otherwise, the fuel droplets tend to separate out, providing only a lean mixture to the engine. On the other hand, the mixing tube is finite and small, then it cannot supply the mixture to the engine at a sufficiently rapid rate at a high speed. In order to overcome this drawback, the downdraft carburetor, that is the second one, is adopted. Uh, it is placed at a level higher than the inlet manifold, and in which the air and mixture generally flow a downward course. Here, the fuel does not have to be lifted by air friction, uh, okay, as in the updraft carburetor, but move into the cylinder by gravity even if the air velocity is low. Hence, the mixing tube and throat can be made large, which makes high engine speed and high specific output possible. A cross-draft carburetor consists of a horizontal mixing tube with a float chamber on one side of it, that is the third one. By using cross-draft carburetor in engine, one right angle turn in the inlet passage is eliminated, and the resistance to flow is reduced. So now, the depending on the number of venturi, that means the multiple venturi system that uses double or triple venturi. The boost venturi is located concentrically within the main venturi. The discharge edge of the boost venturi is located at the throat of the main venturi. The boost venturi is positioned upstream of the throat of the large main venturi. Only a fraction of total air flows through the boost venturi. Now, the pressure at boost venturi exit equals to the pressure of at the main venturi throat. The fuel nozzle is located at the throat of the boost venturi, and this arrangement results the following that I am going to describe. Number one is high depression is created in the region of the fuel nozzle, hence better control over fuel flow and improve automation are possible. At the boost venturi throat, the velocity of air is as high as 200 meter per second. Number two is the annular bracket of the air is formed. The blanket keeps the fuel off and all of the induction tract. Number three is more efficient mixing of air and fuel is obtained without an acceptable reduction in volumetric efficiency. The volumetric efficiency reduces only slightly since only the portion of the incoming air is subjected to the increased pressure drop. Okay, so instead of two or three venturi arrangement in series, we can use in certain carburetors, that is the second one, that is a triple venturi carburetor. There are three venturis. We can say it the primary venturi, secondary venturi, and main venturi. The outlet of the primary venturi is placed in the throat of the secondary venturi, and the outlet of the secondary venturi is situated in the throat of the main venturi. Okay, so the this slide is about the automobile carburetors. In automobile, we use the mainly three type of carburetor, that is Solex type, Carter type, or AC carburetor. Okay, so before going into the details of these carburetors, let's see the important requirements of the automobile carburetors. So number one is ease of starting the engine, particularly under low ambient condition. Number two is ability to give full power quickly after starting the engine. Number three is equally good and smooth engine operation at various load. Number four is a good and quick acceleration of the engine. Number five, developing sufficient power at high speed engine. Number six is a simple and compact in construction. Then good fuel economy, absence of racing of the engine under idling condition, and last one is ensuring full torque at low speed. So this is very important. So now the Solex carburetor. The Solex carburetor is famous for its ease of starting, the good performance and reliability. It is made in various models and is used in many automobile engines. The Solex carburetor is already shown in this slide. Is a down draft carburetor, and this has the provision for simply uh, uh, this has a provision for the supply of richer mixture required for starting and weaker mixture during the cruising the vehicle. It consists of various fuel circuits such as starting, idling, or low speed operation, normal running and acceleration, etc. This figure gives the line sketch of a Solex carburetor. It incorporates a device called bistarter, which is unique for Solex carburetor. Uh, this device is very useful for cold starting of the engine. The various components and the circuits for air and fuel are explained. Um, I'm now going to explaining you for various engine operation. Okay, so number one is normal running. The float, that is one. Okay, with a tapered needle valve at the top face of the float is fixed in the float chamber. This tapered valve takes care of the level of the fuel in the float chamber. The main metering jet, that is number 2, supplies the fuel and air, comes through the venturi, that is number 3. The fuel from the main metering jet then goes into the fuel into the well of the air bleed emulsion system. The emulsion tube has lateral holes, that is shown in the as number 4. Okay, the air correction jet, that is 5, calibrates the air entering through it and ensures automatically the correct balance of the air and fuel. The metered emulsion of fuel and air supplies through the spraying orifice or nozzle, that is number 6, and these nozzles are drilled horizontally in the vertical standpipe in the middle of the choke tube or the venturi. The conventional butterfly valve throttle valve is shown in as number 7. Okay, So now the cold starting and warming. The uniqueness of the Solex carburetor is the incorporation of bi-starter or progressive starter. The starter valves is in the form of a flat disc, that is number 8, with holes of different size. These holes connect the starter gasoline jet, that is number 9, and the starter air sides, the starter air jet sides, to the passage, which opens a hole just below the throttle valve at that is number 10. Smaller or bigger size hole come to opposite the passage depending upon the position of the starter lever, that is number 11. The starter lever is operated by a flexible cable from the dashboard control. Initially, for starting, richer mixture is required, and after the engine starts, the mixture has to be progressively leaned. In the start position, the bigger holes are in operation, the throttle valve being in closed position. The whole of the engine suction is applied to starting the passage, that is number 12. Induction gasoline uh, from jet, that is number 9, and air from jet, that is number 10. The jets and the passages are so shaped that the mixture provide the carburetor is rich enough for starting. Okay, so now the idling and slow running. From the well of the emulsion system, a hole leads to the pilot jet, that is number 13. During idling, the throttle is practically closed, and therefore the suction created by the engine on a suction stroke gets communicated to the pilot jet, that is number 13. The fuel is inducted from there and mixed with the little quantity of air, becoming form a small pilot air bleed orifice, that is number 14. And this form a emulsion which sent down the vertical tube below the throttle valve, but the throttle valve, the idling volume control screw, that is number 15. The idling running adjustment is done by the idling adjustment screw, that is number 15. The idling speed can be thus varied and set to a desired value. Okay, in order to change in order to change over smoothly from the idling and low speed operation to the main jet operation without flat spot, there is a bypass orifice, that is number 17 on the venturi side of the throttle valve, and as the throttle is open, the suction at idle port, that is number 16, is reduced, but the suction pressure is exerted at a low speed opening, that is number 17, and this offsets the reduction of suction at the idle port, that is idle port is 16, and thus spot is averted. Okay, now the acceleration. In order to avoid flat spot during acceleration, a diaphragm type acceleration pump is incorporated. This pump supplies extra fuel needed for acceleration through pump injector, that is 18, number 18. The pump lever, that is number 19, is connected to the accelerator. When the pedal is pressed by foot and the lever moves towards left and presses the pump diaphragm towards left, this forces the gasoline through pump jet, that is number 20, and injector, that is number 18. Again, on releasing the pressure on pedal, the lever moves the diaphragm back towards the right, and in so doing creates vacuum towards left, and the vacuum so created opens pump inlet valve, that is number 21, and the gasoline from float chamber enters the pump. So second one is Carter type carburetor. The Carter type of carburetor is normally used in Jeeps. It is multiple jet plain tube type carburetor with only one adjustment, which is for idling or low speed operation. The combination of gasoline and air is drawn into the nozzle chamber through the jets on the side of the nozzle, forming a tine spray which is carried by a standpipe to the venturi or main pressure passage, where it is absorbed by incoming air, forming mixture on which the engine operates. The jet in the side of the nozzle come into the operation in direct proportion to throttle position. More and more throttle is open, the more jets are in operation. At wide open throttle, all jets are working and engine is getting maximum supply. The low-speed jet assembly supplies gasoline to the engine at idle engine speed and up to approximately 20 km/h. The gasoline flowing through drilled passage connecting low-speed jet chamber with carburetor well. At idling, the gasoline is drawn through low-speed jet and idling port at the edge of the throttle valve. With the idling screw, the mixture of the idle running can be enriched or made leaner as required. Okay, so as shown in this figure, the downdraft cutter, it's a downdraft cutter carburetor. The gasoline enters the chamber, that is number one, which is conventional type, and air enters the choke tube type carburetor from the top. The cutter carburetor is a downdraft carburetor. A choke valve, that is number 2, in the air passage is always fully open during normal operation. The cutter carburetor comprise three venturi diffusing type choke tube. The smallest of these venturis, that is number 3, is above the fuel level in the throat chamber, and the remaining two venturis, that is 6 and 5, are below in the fuel level in the float chamber, and one below the other. So at low speed, the suction in venturi, that is 3, is sufficient to induct the fuel nozzle, that is number 4, and enters the venturi, that is 3, and throws the fuel up against the air stream evenly, thereby providing finally atomized fuel. The mixture from venturi, that is number 3, flows centrally through the second venturi, that is number 5, where it is surrounded by air stream, and finally goes to the third main venturi, that is number 6, where also the fresh air supplies insulated steam from venturi 5. The fuel air mixture enters the engine in a well mixed and atomized state, and then the multiple venturi gives more homogeneous and better mixing at very low speed. Okay, resulting in steady and smooth operation at low speed, and this arrangement is also ensures required quantity for mixture at high speed. The metering system employed is mechanical. Okay, in the fuel circuit, a metering rod, that is shown in number 7, stepped rod is provided, and some is actuated by linkage mechanism connected by main throttle valve. The metering rod being stepped and provides the varying area of the gasoline supply to the jet, and thus metering rod governs the quantity of the gasoline inducted into the engine. Okay, now the starting. In order to start the engine, the choke, that is number 2, is incorporated in the air circuit. The choke valve is butterfly type valve. One half of it is spring controlled. The valve is pivoted in the center. When the engine is choked, the whole of the suction enters by the piston on induction stroke is exerted at the main nozzle, which then provides fuel. Since the air flows is quite little, the very rich fuel air ratio mixture is provided. When engine starts, the spring controlled half of the choke is sucked open to allow the correct quantity of air during the period of warm up. Now the idle and low speed circuit. The rich mixture is very small quantity is needed for idling. The throttle valve, that is point 0.8, practically closed. The entire suction pressure created by the piston in the engine on suction stroke is exerted at the idle port, that is number 9. As a result, the gasoline is inducted through the idle feed jet, that is number 9, and the air is inducted through the first bypass, that is 11, and rich mixture is provided. This fuel air ratio can be varied to get optimum idling speed by the idling screw adjustment. For low speed operation, the throttle valve is open further and the main nozzle also being to supply the fuel. For some duration, during the low speed operation, fuel is supplied by both the main venturi and low speed port, that means the point 12, through the ideal passage. Now the accelerating pump circuit. The purpose of the accelerating pump circuit is to avoid the flat spot in acceleration. The pump comprises of plunger, that is number 13, operating inside a cylinder consisting of non-returning inlet check valve, that is number 14, and outlet check valve, that is number 15. The plunger of the pump to connected to the acceleration pedal by throttle control rod, that is number 16. On rapidly opening the throttle by pressing the accelerator pedal, the pump is actuated and a small amount of gasoline spurts into the choke tube by the jet, that is 17. Releasing the accelerator pedal takes the plunger back by the spring force and in the process sucks gasoline from the float chamber for the exit operation via the non-returning valve, that is number 14. The gasoline is delivered through jet, that is 17, via check out valve, that is 15. The main metering and sole purpose of the main and sole purpose of the acceleration pump is to provide extra spurt of little quantity of fuel during acceleration to avoid a flat spot. Okay, so this pump does not supply any fuel during other situation of idling, running, or cruising and overload. Okay, now the SU type carburetor. A simplified sketch of this type of carburetor is shown in this slide. Okay, it consists of a sliding piston. The lower end of the piston is provided with a taper needle which is inserted into the main jet. When the piston is moved up and down, the needle also moves up and down with a main jet. The upper end of the piston is given a flat form which known as a suction disc. The up and down movement of the piston and the suction disc is guided by means of piston rod and the piston rod guide as shown in this figure. Okay, you can see in this figure the piston always remains loaded by helical spring. The movement of piston controlled by the air passage. The portion above the disc is called the suction chamber, which connects the air passage by means of a slot provided in the piston. The main jet of the carburetor can be moved up and down along the taper needle by operating a lever from the dashboard. The movement is required to adjust the mixture strength throughout the operation range of the carburetor. The carburetor consists of ordinary butterfly type throttle valve. The lower portion of the suction disc is connected to the atmosphere by means of an air rectifier hole, and the upper portion is to the throttle air passage. The system does not have any separate idling or slow running or and accelerating system. Okay, so the weight of the piston is constant and always acts down. The vacuum in the suction chamber always tends to move the piston upward. Therefore, at the particular instant, the position of the piston is balanced by the weight and constant vacuum produced above the piston. In starting, a reaching mixture is needed by the engine, which can be obtained by pulling the jet downwards with the help of the lever attached to it. Therefore, as the throttle is opened, more air is allowed to pass through the inlet due to upward movement of the piston. The upward movement of the taper needle also ensures more flow of fuel from the main jet. Okay, so thus the air and fuel passage are varied with different engine speed and velocities of the fuel, and air remains constant in this system.